Alright, so now that you have some idea of what tan theta means, let's actually look at some real problems where trigonometry is helpful to us. Okay, I want you to turn to page 105 in your textbook and look at example 3. Okay, so let's read this example here. It says that a surveyor wants to determine the width of a river for a proposed bridge. The distance from the surveyor to the proposed bridge site is 400 meters. The surveyor uses a theodolite, I don't know if I said that right, to measure angles. This is basically just a device that measures angles. The surveyor measures a 31-degree angle to the bridge site across the river. What is the width of the river to the nearest meter? Okay, so let's take a look at this. Here's my river. Okay, so here's my river. Again, good idea to draw pictures. And here's my surveyor, okay, with his little contraption. And he is trying to figure out how wide this river is. Right? What is the width of that river? Because when you build a bridge, you got to know how long to build it, right? And if you just think about that, that's kind of a useful problem, right? If you're a guy trying to build a bridge across a body of water, you'd have to know how wide your bridge is, because if you got out there and started to build your bridge, right, and you only bought enough material to go that far, or you thought it was going to be that far, right, as soon as cars start driving on that, they're going to fall into the water. That sucks, right? So we want to know the width of this bridge to help this guy out so he can build his actual bridge. So here's the actual bridge site. This is where the bridge is going to be built, okay? He is 400 meters from that position. He's 400 meters away from there. And he's got this little contraption that he's using to look across to the other side, to this point right here, and he notices that the angle created by looking across the angle created by the distance from him to where the bridge is supposed to be, and the distance from him to the other side of the river where the bridge is supposed to end, that angle is 31 degrees. Right? And so we've essentially created a 90-degree triangle here, right? So this is the bridge right here, and then, yeah. Alright, so now that we've got all the information, let's find the width of the river. Okay? Okay, so let's figure out how long this bridge is. So let's use our tangent ratio. You'll notice that in relation to this 31-degree angle, we're looking for the bridge length, but we're given the side adjacent, right? We're looking for the opposite, but we're given the adjacent. Okay, so let's just label the bridge length. Let's label that x for our unknown side length, and let's set up our tangent ratio and see if we can find that unknown angle. Sorry, that unknown side. So tan of 31 is equal to opposite over adjacent. So the side opposite is our unknown x over the adjacent side, which in this case is 400. Okay, so how do we solve for this x here? Well, remember that tan 31 is just some decimal, right? It's a decimal approximation to what this ratio is supposed to equal. Okay, so we can just pull out some simple cross multiplication that we've been doing for a really long time, right? We just put tan 31 over 1. And we cross multiply. So we multiply 1 by x, so that just gives us x. And then we multiply 400 times tan 31. And you can just enter that into your calculator as 400 tan 31. That's just 400 times tan 31. Alright, so enter that into your calculator and that'll tell us the value of x. 400 tan 31. So that gives 240, and they wanted rounding to, what did they say? Yeah, this is the nearest meter. So just 240 meters. And there you go, right? That's how long a bridge needs, or at least this bridge needs to be, to make it across this river. 240 meters of bridge to make it across the river. So now this guy can keep his job and go home and be happy because he can feed his family, because he figured out how far across the river is, and he can now help his company build that bridge. I want you to just take a moment and pause the video and try the your turn at the bottom of the page. Try the your turn problem. Alright, now that you've had a chance to look at that, let's see what the actual solution is. Okay, so here's a right triangle. right? And the hypotenuse of that triangle is a ladder leaning up against the building, right? And so here's a 90-degree angle, and here's 63 degrees, and the bottom or the base of the triangle is 2 meters away from the wall. Okay, and we want to figure out how far up the wall the ladder is touching. Okay, so again, we're looking for this side here. Okay, here's how far up the ladder is touching on the wall. We want to figure out that height. So again, we set up our tangent ratio. So tan of, in this case, we're going to use 63 degrees equals the unknown side, x, over 2, right? Opposite is x, 2 is the adjacent. So to solve for x, we're going to cross multiply. So I put this over 1, and we go 1 times x is just x, and 2 times 63 is just basically 2 tan 63. Remember, that's just 2 times tan 63. So 2 tan 63 gives us 3.9. What do they want rounding? No, they don't say anything about rounding. We'll just say 3.93 meters. Okay, so this height over here is 3.93 meters. And if you didn't get that, maybe just go back in your problem again. Try it again until you get the right solution.